What's up, everybody? How are you doing? I hope you had a wonderful winter break. Welcome back. We're going to pick up where we left off with Chapter 5, continuing on with triangles. So today we're moving on with Lesson 5.3, which is going to be on the Isosceles Triangle Theorem and the Midsegment Theorem. So real quick, you had 2 weeks to forget everything that you ever learned in this class. So just a real quick review about lessons 5.1 and 5.2 that we did before the winter break. Remember, 5.1 was on congruence and corresponding. Congruence marks tell you which lines or angles are congruent. They will always match each other. One mark matches one mark, or two bubbles matches two bubbles, for example. And corresponding sides and angles must be placed in the same order when you're talking about congruent triangles. In lesson 5.2, we did identifying triangles. You can identify triangles by either its side length or angle type. The three types of triangles by side length are equilateral, isosceles, and scalene. The four types of triangles that we have by angle type is equiangular, acute, right, or obtuse. And remember, we found out that all angles of a triangle have to add up to 180 degrees. So just a quick, brief overview of 5.1 and 5.2 before going on to 5.3. So now knowing those quick reviews, some example problems, find the measures of the missing angles. Remember, all interior angles add up to 180, and exterior angles equal the sum of the opposite interior angles. So if we do this real quick, remember all three of these angles have to add up to 180. We don't know what this one is. This was a box, doesn't have any number, but we know that that's a right angle, so it's 90. So we just add them all together, 51 plus 90 plus our unknown, let's call it x, has to equal 180. We add those two together, 51 plus 90 gives you 141, plus x equals 180. Subtract 141 from both sides. Those cancel, and we'll get x is equal to, let's work this out. We have to borrow. 10 minus 1 is 9. 7 minus 4 gives you 3. 1 minus 1 is 0. So x equals 39. So that angle must be 39 degrees. Over here you have two angles that we don't know. So remember, exterior angles, it says exterior angles equal the sum of the opposite two interior angles. So this is our exterior angle, and it's added together of the opposite two interior. So 42 plus 30 gives us 72. So that means angle 2 has to be 72 degrees. And so angle 1, we could do what we did over here as in our first example. We could add those two together and then subtract from 180. Well, luckily we already did that, so that gives us 72. And another reason of why we can just subtract this from 180 is because it creates this straight line right here. Remember, straight lines always measure 180 degrees. So 180 minus 72, we borrow. All right, that 10 minus 2 gives us 8. 7 minus 7 is 0. 1 minus 0 is 1. So that means angle 1 has to be 108 degrees. So quick refresh, some examples from what we learned before winter break. Okay, the isosceles triangle theorem. Oh my goodness, I'm so sorry, I forgot to mention. Remember, here in Canvas, if you log on to Canvas, you can find the PowerPoint slides and the notes. Here on the home page, I brought Chapter 5 back up to the top. Here are the notes for 5.3. Here are the lesson slides that we're talking about for 5.3. They're on your home page. You can pull those up and work on these while you're listening to these videos. Okay, the isosceles triangle theorem says, if two triangles of a triangle are congruent, then the two opposite angles are also congruent. So remember, we said isosceles means that two sides lengths of the triangle are equal and congruent to each other. Well, what that means is that if there's two equal sides, that means the opposite angles are also congruent. Remember, opposite always means away from, so I always like to draw arrows, right? So we see our congruence lines say that these two lines are congruent, and if we draw arrows that are opposite or away, that means we can conclude and guarantee that these angles are also going to be congruent. Well, that's what this picture shows, right? The opposite angles away from the sides are going to be congruent to each other. That's what the isosceles triangle theorem says. And the converse, shout out to chapter 3, if now it's just the opposite, if two angles of a triangle are congruent, then the two opposite sides are also congruent, right? So again, here we see we have two equal sides. That means these have to be congruent to each other. And if this one has been labeled x, if these two are congruent to each other, that means this one also has to be x, right? So now we could figure out all three angles of a triangle, even though we only have one given to us, right? Same thing. We add up all three angles, x plus 50 equals 180. You can combine like terms. X plus x gives you 2x. Here you would subtract 50 from both sides and get 2x equals 180 minus 50 gives you 130. Divide by 2. 130 divided by 2 gives you 65. So that means both of these angles would be 65 degrees because we know that they're congruent to each other and that they're both x. Okay, so some examples. Find the measure of the missing angles. Well, we see that we have the congruency marks. That means those two sides are congruent. This means it has to be an isosceles triangle, which means that these two angles are also congruent. And we notice that because both of them are labeled B. So again, if we want to figure this out, we have to add up all angles of a triangle. 116 plus B has to equal 180. It rhymes, so you know it's real. All right, combine like terms, we get 116. B plus B gives us 2B equals 180. Subtract 116 from both sides. That's an annoying number to subtract, but let's do it. Once again, borrow. 10 minus 6 gives you 4. 7 minus 1 gives you 6. 1 minus 1 is 0. So 2B equals 64. Divide by 2. And we get B is equal to 64 divided by 2. 2 goes into 6 3 times. 2 goes into 4 2 times. So B would be 32. That means this angle would be 32. That means this angle here would be 32 degrees because they are congruent to each other because it's an isosceles triangle. Okay, now over here, we have something a little bit different now. These are our congruent sides. So again, draw an arrow opposite. Those point to our congruent angles. Well, this time, this one's given to us. So if this one's 68 and these are congruent, we know that this one also has to be 68. And now we have two angles given to us, and we just need to find the third. So for angle 1, let's do 68 plus 68 plus angle 1. That's our unknown. Let's call it x equals 180. All right, so 68 plus 68. 60 plus 60 gives you 120. 8 plus 8 gives you 16. 120 plus 16 would be 136 plus x equals 180. We subtract 136 from both sides. And we get x is equal to, again, borrow. 10 minus 6 gives you 7, or sorry, 10 minus 6 gives you 4. That's a 4. 7 minus 3 also gives you 4. So that means x would be 44. So now, if we write that this one here, let's use a different color. This one here is 44. Now, coming over here, shout out all the way back to chapter 1, we see that 44, angle 1, was that we found is 44. And angle 2, these are vertical angles. So that means these are congruent to each other. So if angle 2 is also 44, okay? And now, a third thing, again, I've told you I like triangles because it's like solving a puzzle. You got to find one piece before you can find the others. Now we see that these two are congruent sides. So that means here and here are congruent angles. We don't know what they are. So if we call this one y, we also have to call this one y. And to solve here, now we know 44, y, and y. These have to add up to 180. So 44 plus y equals 180. Combined like terms, now we have 44 plus 2y equals 180. Subtract 44 from both sides. We end up with 2y equals 180 minus 44, borrow. 10 minus 4 gives you 6. 7 minus 4 gives you 3. 1 minus nothing gives you 1. So 2y equals 136. Divide by 2, divide by 2. I apologize. This is getting really messy. I don't have a ton of room to work with. But 136 divided by 2, 2 goes into 13 6 times. That's a remainder 1. 2 goes into 16 8 times. So y would equal 68. So that means this angle here is going to be 68. This angle here is going to be 68. So in conclusion, if we wanted to make this a little bit nicer, angle 1 equals 44. Angle 2 also equaled 44. And angle 3 that we were trying to find equaled 68. And that would be our answer there. Again, I apologize for the messiness. Okay, so that's Isosceles Triangle Theorem. Now the Midsegment Theorem. A midsegment of a triangle is a segment that connects the midpoints of two sides of a triangle. And the midsegment is parallel to the third side and is half the length of that same third side. Okay, so these are your definitions. Please write them down. You may not get it right now, but we're going to look at some pictures to help clarify, okay? Okay, so our example here, right? If segment AD and equals DB, right? Segment AD is congruent to segment DB. That means that segment or point D has to be the midsegment because it cuts this line in half, right? AE is congruent to EC, again, because E is the midpoint of AC. So that means DE is now the mid-segment because it cuts this line in half and it cuts this line in half. Notice the arrows always mean parallel, so that means DE is parallel to BC, right? And because of the midsegment theorem, it says that it's also half of the length. So that means these two are parallel, and DE, is half of the length of whatever BC is. Okay? Again, let's do some examples. The midsegments of triangle WTN. So remember, WTN is this big triangle here, right? So that means all of the midsegments are going to be these smaller segments in between. If we were to fill these in, an example would be ES. That's a midsegment. ER is a midsegment. And if we use a different color, also SR or RS, doesn't really matter. All right, so those are the three different midsegments of our big triangle. And remember, we said that the midsegments are half of the length of the parallel side. So if ES was to be 5, that is in our red color. So if this was 5, then NT, which is this, get out of there, big one down here, right? These ones match up. If this one's 5 and it's half of the length of this, that one means this has to be 10, right? 10 divided by 2 gives you 5. If SR, which is our turquoise color, is 6, this line is parallel to this line. That means that this is half the length of here. Well, if this is 6, half of what is 6? Half of 12 is 6, right? Then NW equals 12. If ER, that's our blue color, if ER equals 7, then TW, which is this one, that matches with it. This one times 2 would be 14. That equals 14. All right, so that's just for those three. Now, obviously, we have two other ones, and they're giving us different numbers. So if we erase all these numbers here, because now the numbers are changing differently. If NR, so NR is just, remember, just this half segment over here. If this is 18, oh, sorry, let me change the color. if this little piece is 18, that means that RT also is going to be 18. Then ES is half of both of these. Well, this is already half of the whole thing, so that means this one's also going to be 18. And if NR, let's see, where's NR, equals 18, then that's the same thing. Then NT, the whole thing, would be 18 plus 18, which would come out to give you 36. So those are all different types of examples of things that you can do with midsegment. Okay, just some more examples here. Find the measures of angle 1, 2, and 3. Well, let's start with angle 1. We see that we have congruency marks. That's an isosceles triangle. If we draw opposite arrows, that means these two are equal to each other. If we don't know what they are, let's call them x. And since they're equal, if one of them is x, that means the other one is x. So if we show our work, 64 plus x equals 180. Combine like terms, x plus x gives you 64 plus 2x equals 180. Subtract 64 from both sides. We get 2x equals 180 minus 64. Borrow. 10 minus 4 is 6. 7 minus 6 is 1. 1 minus 1, or 1 minus 0 is 1. So 2x equals 116. If we divide by 2, we get x is equal to 2 goes into 11 5 times. That's a remainder 1, which makes us 16. 2 goes into 16, 8. So that means these two angles here are 58. That one is also 58. And we can write in here that angle 1 is 58. Now to find angle 2, if I change the color, notice, right, this here creates a straight line. Remember, straight lines are always add up to 180. So to find the measure of angle 2, we just do 180 minus 58. 180 minus 58. All right, again, we have to borrow. 10 minus 8 is 2. 7 minus 5 is 2. 1 minus nothing is 1. So that means the measure of angle 2 is 122. Okay, and now for angle 3, if we change to a different color, once again, right, we still have the same congruency marks. So that means now this side length is congruent to this side length. And if we draw our arrows opposite, that means this angle is congruent to that angle. Well, we've already used x, so let's just use y now instead. And again, if we set up we know that this one's 122, this one's y, this one's y. Those are three angles of a triangle. So we set it up. Y plus 122 has to equal 180. Combine like terms, that's 2y plus 122 equals 180. Subtract 122 from both sides. Those cancel. 2y is equal to 180 minus 122. Again, we have to borrow. Always borrowing. 10 minus 2 gives you 8. 7 minus 2 gives you 5. 1 minus 1 is nothing. 2y equals 58. Divide both sides by 2. And we get y is equal to 2 goes into 5 twice with a remainder 1. That becomes 18. 2 goes into 18 9 times. So that means this one is going to be 29 degrees. And one final example. Again, same thing. We have some midsegments. Okay, they give us some information. MN, where's MN? MN here is 6. And again, using colors, we know that this line matches up with this entire line here. NI, where's NI? NI equals 5. Remember, this is technically the midpoint. So if that one, just before I even look at what we're trying to find, if I know that this little part is 5, I know that this part over here is 5, which means I know that the whole thing is going to be 10. But again, I don't even know what we're being asked to find, but just getting things done here. And then GH, that's this whole line right here. The whole line here is 8. Okay, so first find HI. HI is the turquoise line. HI here, if the midsegment is 6, that means the entire line has to be twice that, which would be 12. So that means the whole thing is 12. Find MO. MO would match up with blue. So remember, MO, the midsegment is half of the entire thing, and the entire thing we said was 10, which means half of that is 5, so there's 5. Find GI. Well, we kind of already did that. 5 plus 5 would give us 10. And find NO. Where's NO? NO would line up with the red line. NO is here. This midsegment is half the length of the full length, so 8 divided by 2 would be 4. That means this one is 4. Perimeter, finding the perimeter, I'm not too worried about that. We haven't technically talked about perimeter yet, so just leave it alone. And that is all I have for this lesson. Please bring any questions with you to class. I'm excited to see you all. Go Mustangs!